A warm welcome to you. I hope that you're okay this evening. So we're going to be discussing some trigonometry questions, right? So the first one here says prove that that is equal to that. And we know on all proof type questions, we must make sure that we deal with one side first and then we deal with the other. So here I'm going to start with the left hand side, right? Remember, we need to prove that the left hand side is equal to the right hand side. So we need to prove that this x plus 60 degrees minus this x plus 30 degrees, we need to prove that this is equal to cos x. So the first thing we do here is that we have to notice that there is a compound angle there, right? So because there's a compound angle, definitely we need to expand. And when we expand, remember sine is going to become sine x, and then it goes with cos, okay? And then cos 60 there, and then sorry, the sign does not change. And then we say cos x sine 60 degrees. Right, then we say minus. Please remember to use brackets, good people, right? You say sine x cos 30 degrees, and then you say plus cos x sine 30 degrees. And then the moment we see 30 degrees, 45, 30, 45, 60, remember those are special angles, so we'll need our two triangles, right? So the first triangle we need is this one, second is this one. Remember, this one is for 45, so you just say 1 1 1 plus 1 is what? Is 2. Then you put a root sign. Then this one, remember, you will have 30, you will have 60. Then you simply say 1 2 3, then you put a root sign here. So now sine x will remain as it is. Now cos 60, good people, cos 60 means adjacent of 60 degrees over the hypotenuse. Now the adjacent is 1, the hypotenuse is 2, right? And then we have cos x. Sine 60 would be the opposite, which is square root of 3, the opposite, right? Square root of 3 over the hypotenuse, right? Which is 2. And then we'll have minus sine x. Now for cos 30, right? Remember, cos 30 is going to be adjacent of 30, the hypotenuse. Remember, the hypotenuse is this one, good people, right? So when you look at 30 degrees, the adjacent side is square root of 3. So it's going to be square root of 3 divided by the hypotenuse, which is 2. And then this minus times this positive, it will be minus, and then you have cos x sine 30. Sine 30, right? 30 degrees, the opposite side is 1, and then hypotenuse is 2. So this is what we have. Then from there we can try to multiply inside. It's not a must for this bracket to be starting first. You can actually, remember, since this is sine x times half, you can actually write it as half sine x, because a times b is equal to b times a. Okay, so here we can actually say, therefore we have square root of 3 multiplied by half. Remember, now you are distributing this one inside. Okay, distributing that one inside. So you then say, okay, square root of 3 times that is going to be square root of 3 over 2 sine x. And then square root of 3 times square root of 3 there, that will be 3 over 2 cos x, right? And then you have minus square root of 3 over 2 sine x, which is this one. And then this one here, you're going to have minus half cos x. Then from there, we simply say this one will cancel that one. This one is 3 over 2 minus half. 3 over 2 minus half, good people, will definitely give you 1. Okay, so it means that you just have cos x as your answer, which is equal to the right hand side. Right, just an easy question there, right? We'll try to look at more advanced, but this is what we do there. Okay, Next question, we have the following. Prove that the left hand side is equal to the right hand side. So meaning that we must prove that cos A minus sine theta is equal to that there. So I'll give you 5 minutes for that, since it's a 6-mark question, and then we can discuss it. Prove that the left hand side is equal to the right hand side. All right, I hope you had some time to look at that. So we can work on it, right? Um, the first thing we need to do here, good people, is that we need to look at the side which has more information. Remember, this is still a proof type question, like I said. So you firstly work with the side with more information. That means we'll work with the right hand side. Sorry. So we're gonna say sine 2a minus 1 all over sine a minus cos a. Good people, this falls under trig identities, ne? This falls under trig identities. Now in trig identities, some things that we need to remember is that tan theta is sine theta over cos theta, and then it's sine squared theta plus cos squared theta is equal to 1. Then remember your double angle formulae and your compound angle formulae. Then trust me, this topic, or rather this section, is going to be easy. Now usually there are some things, like if you are doing a lot of problems on identities, you will start to realize some trends, right? For example, I already know that if I have sine a minus cos a at the bottom, most definitely on top I must factorize. It's not something that is that you have to say, like how can I put it? It's going to be something you already are used to if you do a lot of problems on this already, because they sine a and cos a at the top you have to factorize in a way. You understand me? And the only way to factorize whereby you will have sine a and cos a, good people, let me tell you right now, when you go back to algebra, we have this expression here, x squared plus 2xy plus y squared. Good people, how would you factorize this thing? How would you factorize here? Anyone? All right. Yes, ma'am.
So you take x as a common factor.
If you do that, you will have x plus 2y and then plus y squared. Then trust me, you are stuck when it's like that. Good people, this is a common expression that they like to use in identities, ne? Please let's know it, ne? Whenever you have to factorize something like this, you're going to open two brackets, and then in those brackets you're gonna have x, you're gonna have x, you're gonna have y, and have y. Okay, then you're gonna have plus and plus. Good people, this is the factorized version of that. Okay, factors of x squared, it's x and x. Factors of y squared, it's y and y. The middle term is 2xy, right? You can see if you multiply here, x times x is going to give you x squared, x times y is going to give you xy, y times x is going to give you xy, y times y is going to give you y squared. So in that way, you'll have x squared plus 2xy plus y squared. This is what I call one of the common hidden treasures. It's a hidden treasure, this one. Okay? And I do not recall myself doing trig identities without coming across this type of factorization. So please, let's know it, good people. Another common type of factorization that I know is hidden, that they ask you in identities, is the following. How would you factorize the following? 2x squared plus 2x squared plus x plus 1. How would you factorize this? No, sorry, here usually it's gonna be minus. Yeah. How would you factorize this? Going once, twice. So Okay, so how would you factorize this one? Good people, you just open two brackets. You say 2x, you say x. Then you're going to say the 2 is going to multiply a number you're going to put there. So if you put 1, you're going to have 2 times 1. However, you need positive 1 as your middle term. So maybe 2 times 1 should be positive, so that when you say minus 1, you're going to get positive 1. 2 times 1 is 2, and then minus 1 is 1, which is the middle term. So that's what you're going to look out for. The negative 1 times a positive 1 is this one. So this is also another hidden treasure. Okay, it's another hidden treasure, meaning it's a tool you need to use, but it's they don't really give it out to you straightforward as this. Alright, so enough about my hidden treasures. Let's see how we can do the problem. Let's see how we can do the problem. Now, like I said to you, right, so you're gonna work with one side. So this is the right hand side, right? So you write that the right hand side is this. Now, good people, since you have sine 2a, there is no way, good people, that when you are given sine 2a, you are not going to expand it to 2 sine a cos a. There is no way. It's part of the double angles that I told you about. And at the moment we see 1, good people, let's remember this. The moment we see 1, let's remember this. So we can actually say this is sine 2 sine a ne, cos a, and then you say minus into sine squared. Since we are dealing with a, you can write sine squared a plus cos squared a, because remember 1 is equal to sine squared theta plus cos squared theta, all divided by sine a minus cos a. Then you go down with it. You're gonna have 2 sine a. Where did I get the theta here? Sorry, it's a there. Cos a minus sine squared a minus cos squared a, all divided by sine a minus cos a. Now, good people, to make things very, very easy, when you are at this point, you are more than welcome to say, because you see that these two are multiplying each other and stuff, right? You're more than welcome to say, let sine a be equal to y. Be equal to, yeah, same thing. Can say y or x, whichever one you want. I'll just let it equal to x, and then let cos a be equal to y. Right. So what does this mean? It means that I have 2xy and get minus x squared minus y squared all over x minus y. Now, why am I writing it this way? So that I can actually tell that, oh, it means we are talking about the hidden treasure, which is this one here. Remember, that is the hidden treasure. So I must have x squared first, which means I'll have negative x squared plus 2xy minus y squared. Okay, all divided by x minus y. However, here we need it to be positive, so you can take negative as a common factor. You have minus 2xy, and then you're going to say plus y squared there. All divided by what? All divided by x minus y. Then what you simply do, good people, is that you're going to factorize the bottom part. Remember, we said the factorized version of this is this, and then it's that again. However, since here there is a minus instead of a plus, how we're going to factorize that is that we're going to open our two brackets. Then we say we have x, you have x. Now you're still going to have y and have y. However, because you need negative 2xy, you will put negative and negative. If you need 2xy positive, you say positive and positive. And negative y times negative y gives you positive y squared. all divided by what? By x minus y. Now if I remove those unnecessary big brackets there, this is what we have. From there, what do you realize, good people? This bracket on the bottom will actually be equal to the bracket on the top, right? Which means that you're going to have negative x minus y as your final answer, which means you're going to have negative x plus y, of which you can write this as what? You can write it as y minus x. Then you come back here. What did you say is y? Remember, you said y is cos and you said sine is x, which means here you have cos a, which means you have cos a minus sine a. And then, good people, this should be equal to the left hand side. You can check the left hand side, good people. Remember the left hand side? It was cos a minus sine a. That's what you have there. So this is how to navigate through trig identities. You firstly have to remember those things I told you about and remember the factorization methods. Then you're going to be fine. Any question here? All right. Then we proceed. Sorry. Let me check if I have the other one here. Yeah, very nice stuff. Prove the identity. I like identity questions, good people. Like, yo, they're very, very nice. Okay, so this one, due to time, I'm going to walk you through it. Because I know it actually involves some other type of stuff, right? We need to talk about. So now the left hand side, good people, is more juicy, you can see. So it means that we're going to work with the left hand side first. You say cos x minus sine x, sine 2x, right? All divided by cos 2x. Then from there, what do? Already you have sine 2x again. There's no way. You have to turn that sine 2x into its double angle formula. So you will say, okay, we have cos x, you have minus sine x, and then you're going to say 2 sine x cos x. You have no choice, good people. You have to do that. And then here you have a double angle formula for cos. The only part that is a bit tricky is the double angle formula for cos. Okay, so for double angle formula for cos, remember that there are three options. You can write this as what? As cos squared x minus sine squared x. Okay, or you can write it as 2 cos squared x minus 1, or as 1 minus 2 sine squared x. Right, good people, I need you to master trigonometry. Get total straight on trigonometry. With these tools you'll be fine. So what you do is that you just have to keep this next to you or near you so that you're going to use it later on. So do not rush to convert this. Just leave it as it is for now. Work with the top part. Okay, now here you have cos x minus, now sine times sine. Okay, you have a 2 there, okay? So you can say 2, and then you have sine squared x, right? And then you have what? Because the sine squared x is sine x times sine x, gives you sine squared x. And then remember, you're not going to say sine times that, because these things here, there is no a plus separating them or a minus. It's a multiplication there. So you just have to say the like terms, you multiply them in that case. Right, so it means that you have sine squared x, and then you're going to have cos x. Please don't say this times that. No. Then we divide by what? By cos 2x. Now on top there, it looks very, very interesting. Very interesting. There is a cos here, there is another cos. Factorization is very key. So you're going to factorize there. Say you have 1 minus 2 sine squared x left. Good people. Yo, trigger identities are nice. What do you realize here on 1 minus 2 sine squared x? Isn't it this one? So we just say, because it is this one, we can actually rewrite it what? We can actually rewrite it as cos x, and then you say cos 2x. You can rewrite it as cos 2x, okay? And then here you have cos 2x. They cancel, right? They cancel here. Your final answer will be cos x, which should be equal to the right hand side. Didn't they say x there? Yes, they said x. So it's here you are just playing, right? Very, very nice stuff. Another way is that you could have said, no, maybe you leave the top as it is, and then, right? So this is just alternatively. You could have said maybe you have cos in x into 1 minus 2 sine squared x, all divided by what? By cos 2x again. Now that you would have seen something like this, that's when you say, oh, now I have to change cos 2x. But I'm going to change it to this one, since on top that's what I also have. So we change the bottom part to 1 minus 2 sine squared x. In that way, this bracket was going to cancel that. You are still left with cos x, which is equal to the right hand side. So that is how you would solve it there. Very, 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 very nice and easy. Any question? All right, next one. This was the homework I gave them yesterday. Quite also an easy homework there, so we're just going to this is too easy. Okay, check. This one here you can see what is happening. You have sine of an angle, cos of an angle. You have cos of an angle, sine of an angle. That should remind you of what? Compound angle formula. And because it's sine and cos, remember that means we are dealing with a compound angle formula for sine. For sine. Because sine is like a man, he like to share. So then you say, remember, this will be your A, B, A, B. You just have to make sure the angles are the same, and yes, they are the same. So for 5.3.1, you would just say 2x plus 40 degrees. Remember, the sign does not change. For men. Then you have, that was your A, and then your B, it's x plus 30 degrees. Which means you have sine into what? Into 2x plus 40 degrees minus x minus 30 degrees, which means you have what? Sine 2x minus x is x, 40 minus 30 is what? 40 minus 30 is 10 degrees. Then you would be done for A. Then they said determine the general solution of the following. They gave you sine. You know this whole thing from the previous question. We found it to be x plus 10 degrees again. Then they say it's equal to cos into 2x minus 20 degrees. Now for general solution, at that one I think we need actually just a session on it, ne? But however, if you have sine and cos on both sides, good people, you're simply going to change one of them to be the other, which means you're going to say this is sine x plus 10 degrees, ne? It's actually a special case of general solution. So this cos, you can write it as sine as what? As sine 90 degrees minus this whole angle, minus 2x minus 20 degrees. If you do this, remember, sine 90 minus an angle, it's a co-ratio. Sine will change to what? Cos of that angle. So it means it's still the same thing. Then now that it's sine and sine, that was the goal. You then say my reference angle will be equal to 90 degrees minus 2x minus 20 degrees. So meaning you're gonna take what is inside as your reference angle. And then simply you can then say you have 90 degrees minus 2x plus 20 degrees, which means you have 110 degrees minus 2x is the reference angle. Then from there you go to the different quadrants, right? Like I said, we shall talk more about this maybe on its own nice session there. Let's see what we also have maybe for today before we go. Yeah, what a good question here. What a good question here. You can give it a try. You can give it a try. I'll just give you 4 minutes. All right. I hope you had a look at that, and I hope you were able to work on it. Uh, Quite an interesting question, right? Because once it starts with x minus 360, that tells you that okay, it means that we are dealing with a negative angle. Why a negative angle, right? Well, this is because usually we want to say 360 degrees minus x, or we want to say 360 degrees plus x, okay? But the one that we usually wanna use, like when you're looking at this, it's x minus 360. It reminds us of 360 minus x. Usually we want to start with an angle first, and then after that we go to the variable here. Okay, so we start with the angle first and then the variable, but this one is starting with the variable first. That should tell you that it's a negative angle. Okay, so how do you resolve that, or rather how do you solve that, right? So there is a longer method of doing it, right? Because you don't want to make mistakes in most cases, right? So now what I usually then say is that you can write it again as cos. However, I want you to start with 360 degrees, and then I want you to end with x. Now, in terms of the signs, remember that 360 was negative, and then x was what? Was positive. But in order for you, like, okay, you can rewrite it like that, even though it's going to take a lot of time, but in the end, it's very much worth it. Worth it, right? And then we'll say sine 90 degrees plus. Now, remember that one is a co-ratio, whereby sine will change to cos, okay? So it means that it will be what? Cos x. However, is the cos x positive or negative? How do you check? You go to your calculator, then you are simply going to type in for me sine 90 degrees, and then for x please use 20 degrees. Just put in sine 90 degrees and then just put 20 degrees there. Not focusing on the answer that much, we just want to know that is it gonna be positive or negative. Please do that and tell me, is it positive or negative? Sine 90 plus 20 degrees, is it positive or negative?
Positive, sir.
Great, it's positive. Another thing to look at it, another way to look at it, here's how why I like 20 degrees. Remember our cast diagram, right? On our cast diagram, remember that we have 0 degrees here, we have 90 degrees here, and then in here we have 180 degrees. Now remember, I usually said 90 degrees minus theta is in this quadrant, and then 90 degrees plus theta is in that quadrant. Now if you get something like sine 90 degrees plus x, obviously you know that because it's 90 minus or 90 plus, sine is going to change to what? To cos. Immediately write it, and then cos 90 degrees plus x is going to change to what? It's going to change to sine x, because it's like that. Okay? However, you want to know whether it's positive or negative. Since this is the quadrant, there, ask yourself, in this quadrant, in this quadrant, how is sine in that quadrant? Sine is positive in that quadrant, so it means the answer should be positive. Then you say, how is cos in that quadrant? Cos is negative, right? So the answer should be negative there. So in that way, you are using the first quadrant. I think it's very much effective that way. To say, yes, you know that sine 90, let me even start it afresh. Good people, I'm very passionate about trigonometry, that I want you to get it all the time. So this is what you do. You are faced with sine 90 degrees plus x. Definitely you know that because it's 90 plus or minus, 90 plus or minus theta, these are what? Those are your core ratios. Okay, those are the core ratios. So it means that sine will change to what? Will change to cos x. However, is the answer positive or is the answer negative? You just look at this quadrant as the second one, and then you say, how is sine in that quadrant? It's positive, right? So the answer here should be positive. And then you go to cos 90 degrees plus x. You're simply going to say 90 plus is going to change to what? To sine x. However, is the answer going to be positive or negative? You say, in this quadrant, how is cos? Cos is going to be negative because it's only sine which is positive in that quadrant. Okay? Then you always get it correct. So here is going to be cos x, and then plus, we have cos squared minus x. This one, good people, when you see a squared there, just rewrite it but put the squared outside like this and then continue there. Then this one, since it's now like this, good people, you are more than now allowed to take out a common factor there as negative, and then you'll have minus x. A multiplied by cos x, and then plus. Now, good people, inside there, cos minus x is a negative angle in the fourth quadrant, and cos is positive in there, so it means you're gonna have cos x all squared minus 1. From there, what do you have, good people? Remember that once you have negative of a certain angle, that is a negative angle, and negative angles are in the fourth quadrant. Is cos positive or negative in that quadrant? Cos is positive again, so you're gonna have positive cos that angle, which is 360 degrees, minus x multiplied by cos x, and then here you're gonna have cos squared x minus 1. Then here, good people, 360 minus is still the fourth quadrant, whereby cos is positive, so you have cos x times cos x plus cos squared x minus 1, so it means you have cos squared x plus cos squared x minus 1. Right, now what is cos squared x plus cos squared x? That will give you 2 cos squared x minus 1. Now what does this one remind you of? Do you still remember here? 2 cos squared x minus 1. Right, so that means that this one here is going to be cos 2x. Is the double angle formula for cos 2x, because they wanted to a single trigonometric ratio. Is this clear? Any question? No. Okay, in the absence of questions, good people, I hope
Sir,
that, yeah.
sir, you see the first answer on the first line of the answer, and then the second one. You see where it says plus cos x, and then
Wait, like is it this one? This one
how
here?
did I get
This
the
one?
first line we had negative x? No,
Oh,
on top.
this one.
No, sir, the last one with the negative one. Yes,
Oh,
that
here.
one. But
Oh, this one.
you see, the second one,
This one.
and then go for what?
This one.
The first, the one that you did.
We go here.
Yes, this one.
Yeah.
How did you get x, yet on top it was negative x?
Oh, okay. So when you look at inside there, right, you have cos minus x, which means it's a negative angle. So you must know that cos negative theta is equal to cos theta. Sine negative theta is negative sine theta. And then tan negative theta is negative tan theta. This is because we are talking about the fourth quadrant for negative angles. Okay, so since I had cos negative x, I then said that should give me cos x according to this. And then from there, I then say cos x times cos x is just cos squared x. Is it clear?
Yes, sir.
Okay.
Sir,
Mm-hmm.
so what you see for that one,
Mm-hmm.
we expand it and say the one is sine squared x plus cos squared x. Would it be correct?
Or if we're on top there, like we do it here.
No, like like even if you do it like at the second last step,
Here,
you
all
write
right.
yes,
Okay.
you write it as sin squared x plus cos squared x.
Let's see what we would have. So we would have 2 cos squared x minus sine squared x plus cos squared x. Very nice, right? So what would we have? You would have 2 cos squared x minus sine squared x minus cos squared x. Yeah. So good people, what will this give you? This will then give you, remember you have 2 cos squared x minus cos squared x, which would give you cos squared x, and then you have minus sine squared x, which brings to you to the first formula for the double angle of cos. So it means even if we did it that way, we'll still go back to the fact that this is actually cos 2x. I hope that is clear then. All right, so I hope that was clear. More practice, good people. Happy learning and all the best.